Okay, everybody. Just a couple errors that I made. There were two errors in this video. First, because for flux we need the normal vector at the surface, actually the unit normal vector. I took this equation here and tried to make it so that we could write our surface as a contour of some map, the zero contour, the zero level set. But I messed up because although I subtracted the x squared to become a minus x squared, I didn't subtract the y. I added y. That is wrong. It should be minus y. Then if this equals 0, this and this are the same, right? So I made a mistake. That plus should be a minus. Now our surface is the zero contour of this map, which means we can get the unit normal vector at the surface. We need that unit normal because flux is the integral of the dot product of the unit normal with the vector field. That is what flux is. This is a function on the surface. We integrate this function on the surface. Okay. So let's see how that minus sign goes through. This gradient was basically, I took the partial y of this function, and because I had a plus, I wrote plus 1, but it should be a minus 1. Then I squared it, and it goes away. So actually, it didn't affect anything because when I take the norm, it squares it here. So this is correct still. But then, you see here, I used the gradient again, and so this should be a minus because that's a minus y, okay? And this should be a minus sign. And 0 times minus 1 is 0. So actually this minus sign didn't affect anything at all, and it was okay. Okay. Second error. So the first error didn't affect anything. I was just lucky. Now the second error did affect something right here. When I integrated, first I found the antiderivative, and then I plugged in, and then I said, well, minus a half plus a half, that cancels, and then this minus y magically became a plus y. And I have no idea why that happened, but this should be a minus y, which then means I'm integrating minus y. So the antiderivative needs to be minus y squared over 2, which means when I plug a 1 in to y squared over 2, I get minus 1/2. When I plug in 0, I still get 0. And so my final answer is minus 1/2. Okay. And so there are my two mistakes. One thing I might have added, looking back on this, is I might have said in words right away that, computing flux, I would have written this somewhere, computing flux means integrating the dot product. What function? We're going to integrate a function. We're going to integrate the function that it takes the dot product of our vector field with the unit normal vector. With the unit normal vector of the surface. And that is what I would have written in words. I think I definitely said this in my answer. But just saying, what is computing flux? Well, it's integrating a certain function on the surface. What is that function? It takes every point on the surface and spits out a real number, which is the dot product of the unit normal and a vector field. Okay? So that's why we say that we compute the flux of the vector field through the surface. Through the surface means the unit normal vector. We're going straight through the surface, 90 degrees through it. Okay? And that's the only comments I have fixing my two errors